I am recording in progress. All right. So today is January 31st. We have a lab today, which I will post right after I get back to my office. And today will be our first lesson on basic graphics. Any questions before we start? All right. So I'm going to go to where I have my IntelliJ loaded up. I promise. All right. So here's my IntelliJ loaded up. I'm going to show you some basic graphics applications that I have made. So this is going to be sort of learning how it works by example. All right. I don't have any formal documentation as such because I change it every semester I teach. I change it around. So whatever worked last semester won't compile and run this semester, that kind of thing. So all right. So let's look at one of my favorite start. Let's start with one of my favorite examples. Hold on. I need the sharing thing to go away. Come on. I need the top of my screen. Come on. Oh, come on. Why is it doing this? Normally it just goes up on its own. Today, it's refusing. All right. I have to make this smaller. And Windows. All right. I have to stop the sharing, I guess. All right, I resume sharing. Okay. So now, hopefully, I didn't do it. I didn't move it enough. All right, I have to stop it again. All right, now let's go back to sharing. Okay, finally, I can run the flyer. Okay, so this is how the flyer looks. It'll take just a second to start up. What you can see is, okay, so we're gonna go through each of these classes. And let me just widen this while it's contemplating. There we go. So this is the way the game starts up. There's a splash screen. It's got like a starry background. It's got a start button and it's got a random second button that serves no purpose. It's just, so you can see how to put a button there. But if I press the start button, then I get this screen where I get the Millennium Falcon flying across a starry background. And if I want to shoot, I press the space bar. Now there is sound. Let's see. You know what? I bet I know what the problem is. So Windows very cleverly uses, yep. My Windows system thinks this is a speaker and it tries to play sound through it and it fails. Now, no, still did not play. All right. Well, that makes a sound. Trust me. There's like a little boop and then explosions. And I can use the arrow keys. Guys, could you stop talking, please? And there's these little arrow keys that I can use, right, to maneuver around. All right. So that's how that game looks. I mean, it's not a game, right? It's just sort of the element of a game that you could put together. So let's look at the code. All right. So if you go into the basic graphics package, there is a thing called basic flyer, and that's where we are. And there's 3 classes in there: Falcon, Flyer, and Plasma. The package is basic flyer. So there's some imports which are hidden. Okay, I have a constant static int plasma size, which is 10, and then I have my main method. In my main method, I have a couple of what are called reusable clips. This is how you do the sound in this system. You put the name of the sound file here. It pretty much needs to be a wave. And inside basic graphics, there is a sub package called sounds. Okay, any sound files that are in there should wind up being available to the game. Okay, so you just put them in there, and then when you say reusable clip, it should just load. Okay, so that's how you make the sounds work. And when you create your final projects and you upload them, you want to have the sound files in that location. I have an upload checker, which you've probably seen the link to. And when you go to upload, it's going to sort of check that you've done that. Now, I have a limit on the upload size. If you have the notion that you want to take a 12 gigabyte sound file and attach it to your game, don't. Okay. I mean, I've told people they could put images and sounds they want, but then they get 12 gigabyte sound files. I don't know where people find those, but we don't want that. Okay. Just try to live with less. All right, so we have clip and boom, basic frame. So basic frame is kind of like the foundation of any graphical application that you build with basic graphics. It's JFrame if you're using Swing, but we're not going to use Swing here. If you explicitly invoke JFrame and put it in your code, you will get a 0. That's in the instructions. Okay. So one of the things that you might want to do with your graphics application is have what's called a card layout. Now that's what I have. That's what I showed you in the basic flyer. First, we had a card which had a splash screen and a start button on it. And when I pressed that start button, I switched the card to showing the sprite component, which is where the flyer lives. Okay, so I'm going to show you how to do that also in a minute. So getting card gets the current card. And then I can set a painter object. I'm going to create a background painter, and I'm going to give that background painter a picture called freespace.ping. Freespace.ping is that background you saw on the splash screen with the sort of goofy stars on it. So that shows you how you can set a background on things. Now, the picture objects are kind of like the wave files, right? Anything that you put in the images directory is going to be available to you as a picture, right? And here, pings and GIFs and other things will work. It's not just one thing. So if you put something there, it will automatically find it and it should work, okay? And again, the checker is going to try to check that you've uploaded the images. Yes. Name? Kaysen. So is a card like that? A card is the whole screen. So you want to think about a card as the whole layout, everything on the screen. So, yes. So then if you use a card, then say when you have a how yes. A card and a scene. Okay, so the card is for the basic frame itself. It's for the overall whole application, right? And one of the things you can put on one of the cards is the thing called a sprite component. And the sprite components have scenes. Okay, and your sprites are attached to different scenes. So if you've got like, you picture you've got a fighter with facing 12 orcs, right? That can be on one scene, and then on another scene, and it can have a certain background with it. And then on another scene, you have a bunch of different characters with a different background. So it's a scene is going to have a combination of characters and background, and it's all going to live inside a sprite component. And a sprite component will live on one of your cards. Make sense? It should eventually make sense. And we'll have 4 labs to work our way through this, and well, 5 if you count the lunar lander lab that we're going to have. So we'll have 5 labs roughly for you to work your way through this, and at the end of the time, you should be able to do something with it. I think it really winds up being a simplification over what the Swing does for a couple of reasons. One is that I isolate you from the threading system. threading is one of these things in Java that looks deceptively simple. You create this new thread object and it does things independently of the other thread objects. But that turns out to be a very complicated thing because threads interact with each other in unpredictable ways. And one of the purposes of basic graphics is to shield you from that. Okay, so here I have my painter that I use for my game, right? So I can use just a static image like a ping or whatever as a background painter, but here I decided to draw one myself. And so this painter object has got a paint method, which takes a graphics and a dimension. So that's the size of the area it's painting. In this case, and then the graphics object has a number of different methods on it. Like you can set the color of your pen, and then you can draw a rectangle and fill it with fill rect. And you can set the color again. I said first blue, then pink, then I'm going to fill another rectangle. So what I'm doing with these rectangles is, you might remember on the game, there were these little borders around the edges that were different colors. And that's what I'm drawing here. All right. And so I do all those various rectangles. Then I do a black and I color the background. Then I have a constant for the number of stars I want to draw. And then I have I create a random object. Random comes from java.util.random. And then I do what's called setting a seed. So random numbers in Java are not random. They're a sequence of, they start somewhere and they provide a sequence of numbers that look random to a human. But they're actually deterministic. And what they do is they figure out a starting point for that highly random looking set of numbers by setting a seed. Now, by default, it's going to set the seed with something like the current time or the process number or something that's going to change every time you run your program, thus preserving the illusion of randomness. But what I want to do is I want to get the same set of so-called random numbers every time. So I'm going to set my seed to 0. I could pick any number there. I could pick 100. I could pick 12, whatever. It doesn't matter. It's going to give me some particular set of random-ish numbers. Okay, and then what I'm going to do is I'm going to go through my number of stars, and I'm going to create a random diameter and a random position on the screen, and then I'm going to draw them with fill oval. Okay. Now, just to sort of, and what that does is that creates a nice stable picture of the background stars. What happens though, if I don't set the seed? So if I comment that out and I run it, what do you expect to happen? Anybody? Yes, Scott. Every time I draw the background, the stars will be in a different position. Yeah. So let's see what that looks like. So that's different random numbers every time, right? But if I set the seed, that, yes, Logan. I don't know what the frame rate actually is on this game. It's not terribly high. It's actually, I have it set in here somewhere. We're going to see it in a minute, but it's not going to be, like you get your other games where that's billion frames per second. That's not what we're going to have here. This is, you got to scale your expectations down here a little bit. Well, look, I mean, if you really want the super high performance for a game, you're not going to use Java. And chances are you're going to have to spend like more than a semester's worth of time coding something. If you really want that ultra high performance, it's just more work than this. This is going to be slower, but it's also going to be a lot simpler. All right. So next I'm going to create the sprite component. The sprite component is sort of the arena where all the sprites or characters, if you will, they all live, work, and play. Okay, they all stay in that thing, and you generally only want one of them. It is possible to have more than one, but generally you only want one of them. Okay, so each sprite component has a current scene, right? And then you assign a painter to that scene. And in this case, I'm just taking that painter I just showed you, that star thing. Now you might notice that when I created that painter, right, what was I doing here? I was creating a what? Yeah, but syntactically in Java, what did I do? What is that? I have new, I have a class name, I have parentheses, I have an open curly bracket. Yes. What? I can't hear you. It's a new object. Yes. What's your name? Simeon. It's a new object, but more specifically, it is an anonymous inner class, right? Just trying to get that concept, hammer that concept home. All right. Okay, so here is the layout for my splash. Okay, so this is going to, for this, I'm going to use a 2D array of strings. And in this case, the array just has a single column. I'm going to have title, button, and button 2. And these are just sort of placeholders on the screen. So logically, what I've told the graphic system is logically, I'm going to have 3 parts to my screen and they're all in a vertical line. And later I'm going to tell it what things to put at each of those positions. So, and then I set that, I create that splash layout and then I set it on the card that I'm currently working on, right? Okay, so now I'm going to create something called a J label. That's part of the swing platform. It's just a standard thing. I'm going to set it to fly or game. I'm going to set the foreground color on it to white because I want the text to be white. I had sort of a black background, and if I took the default black text, you wouldn't be able to see it. And then I add the title to the background. Okay, then I create a J start. Then I create the button J start, and that's just a J button. Now, whenever you create a J button, you want to provide it with an action listener. An action listener is the thing that tells the system what happens when a button is pressed. And guess what that is? Guess what that thing is? I have new, I have an interface name, I have parentheses, I have an open curly bracket. Anonymous inner class, right? Okay. So inside that anonymous inner class, I have action performed and action event. And what I'm going to do is I'm going to say bc2.showCard. That's going to change the card to the one with the spaceship on it. And then I'm going to have say bc2 set focus. This is just a bit of incantation that you have to do, right? So you want the thing that's currently in place, the thing that you've just put at the forefront of the screen to be the thing listening for mouse and keyboard events. And for some reason, that isn't the default behavior. You have to tell it. So there you go. You tell it. Now, let me just go back up here. I wanted to call attention to something I missed. So I had 2 cards, right? I did a get card once and I did a get card a second time. Each time I do a get card, it's going to create a new card for me to use, right? The first one I get is the one that's going to display first. And the second card, well, I have to, if second, third, whatever, however many cards I have to switch to that card. And in this case, I switch to that card by calling show card. Any questions? Yes. Yes. What's your name? Kobe.
So for the show card, if just because there's only one other card, does it automatically pull that card?
So does it automatically show which card? I did specify which card. You do have to specify which card, right? So because it's BC2, that's card 2, basic card 2. It's going to show that one. So yes, you do have to specify it. All right, clockworker.initialize speed 7. Okay, so somebody asked me about the frame rate. Here it is. So the way the background is updated is it's updated every so many milliseconds. In this case, for this application, I picked 7 milliseconds. Okay, it's going to update every 7 milliseconds. And if I don't call that initialize thing, then none of my graphics are really going to do anything. My Millennium Falcon is just going to sit in one place and it's never going to be able to fire because it's requiring this clock worker to do that. And the clock worker hasn't started working, then nothing's going to happen. Okay. So this is something that you need to call in your applications. I had a student last semester who somehow didn't hear me say that. and he coded his application, and he sort of wound up rewriting a clock worker and trying to build all the same infrastructure himself over again on top of this. It was not pretty. All right. Okay, so here we have what we're doing is we're adding the buttons. I have the JStart and my random extra J button, which has no action listener on it. I'm adding them, and I'm adding them at the location. So this is at button, and this is at button 2. And those are the things on my layout here. And now that I look at this, I realize I have a slight bug, and I guess it worked anyway. But I should have put title here. So, right, to specify which of the pieces of that layout that I want to attach that item to. So I've attached the title to the first one, the start button to the middle one, and the random button to the one on the bottom. And I can have as many of those little labels in my layout as I want. Yes. So I don't know exactly how it was still able to work, but I guess Java just sort of defaulted to something. And that something happened to work. Let's just see what happens. Let's see if I'm just going to run my application again, and we're just going to see if that changed anything in any noticeable way. Okay, so there's my flyer game thing, and there's the start, and there's button 2. So it looks kind of the same to me. So I guess everything is all right. And where is the edge of the app so that I can pull it down and make it go away? I can't find it. All right, I'll start it. It's up here. Okay. And I have to drag it this way, and then I can see the X. All right. All right, any other questions? Yes. Name. Okay, so the question is, how is the sprite component involved in all of this? So the sprite component is going to be the thing where the sprites live and move, and they have to be on a sprite component to do those things. So we'll show you the details of that in a minute. Yes.
So can different sprite components interact with each other? Like, could you take
Yes, different sprite components can interact with each other. There's a sprite collision listener, for example, that you can overload and make use of. And I'll show you that also. Okay. So, all right. So I'm going to create another layout. I'm going to have a basic layout. This is just a different way of doing a layout. So the other way I showed you, you could create an array of names, and you could put things in different places based on the names. Here's another way that you can do it that's kind of a little bit more like an HTML table layout, if you're familiar with that. You give it a sort of a virtual coordinate, X, Y, and a width and a height, right? And then you can sort of also imagine your virtual layout that way in terms of these virtual coordinates. If you want to have, so in this way, what I could do is I could say each of the 3 things has a box of 1 by 1, and I could put X equals 0, Y equals 0, X equal 0, Y equal 1, X equals 0, Y equal 2. And that would also give me a vertical layout of 3 things. Okay. So I have 2 ways I can do these layouts. I can either do it with the strings and create a table, or I can use it with these virtual coordinates, depending on what seems easier. Yes. So the point of these layouts is to get it automatically spaced so that you're not fiddling with different numbers. And also when you resize your screen, it sort of looks okay. It's probably never going to look perfect. Yes, Ty. Not well, you can in the sense that if you put at one of the layout positions, you put another container or J component or something, and then you can add one of these layouts to that. You could do that. All right. So bf.show. bf.show is that's the basic frame show method. If you don't call bf.show, nothing will show up. So bf.show says start everything up. Show me a window. All right. Final Falcon F. So Falcon is my sprite. It's going to be the thing that flies around, and I set the focus of this. Right here, I have a feature which is commented out, and I realized this morning that I broke it. So hopefully I'll have that fixed before the next class. And I'll tell you about it then. Remind me to. I defined an increment, 2 pi over 100. So this increment is for turning. So every time I press like the left or the right arrow keys, I'm going to turn an amount equal to incr. That's what I'm telling it. Now I'm going to add a key listener. I'm adding this to the second card, the basic card. And so add key listener, I'm going to add a key adapter. Anybody recognize this construction? We have the keyword new, we have a name, we have open parentheses, we have an open curly bracket. You recognize this construction? No, what is it? I've never seen it before. It's an anonymous inner class. Okay. So inside the anonymous inner class, I have a key pressed method and it takes a key event. The key event is going to have a key code, so I can get VK right is going to be my right key, and my VK left is going to be my left key. The key event and the key adapter and all that stuff is part of the standard Java API, and you can look it up there and look at standard documentation for those things. So what I'm going to do, my Falcon's going to rotate. I'm going to call the rotate method with plus incr on a right key, with minus incr on the left key. So that's just turning it. Then if I press the space bar, so get key char equals space, I'm going to create a plasma bolt. So new plasma PL, and I'm going to, now each sprite has to be initialized with a scene, right? Because it lives in a scene. So my Falcon, when I created it up here, I put the scene in there, the current scene, and I'm doing the same thing with my plasma bolt. So now what I'm doing is I'm setting the velocity, the X and the Y component of my plasma bolt. And the way I'm going to set it is I'm going to set it to, for the X component of my velocity, I'm going to get the velocity of the Falcon and double it. And for the Y component, I'm going to get the velocity of the Falcon and double it. So the plasma bolt is going to go twice as fast as the Falcon in the same direction. So that's how I get it to go the direction I want. Does it make sense? You have to just sort of, understand that little bit of math. All right. And okay, so one of the things I don't want you to do is use the sleep method on thread. If you're using sleep, you're interfering with my whole system and messing things up. Excuse me. If you want to have timers for things, right, what you can do is you can create these clockworker add task. And in this case, I have an anonymous inner class to create the task. And in the constructor, I pass the number of steps I want the task to have. So if I want the task to just last for 10 ticks of my clock, 10 of those 7 millisecond intervals, then I specify it there. And then it does those things and then it goes away. If I don't specify a number of steps there, it'll just go forever. Inside my task, I have access to the current iteration. That's how many times I've run. And the max iteration, which is what I initialized it with. And I can decide how I want to do things in my clockworker based on that. And here, what I'm deciding is I'm going to change the size of my plasma ball and the color of my plasma ball based on how long it's been since I shot it. Okay. And you can work through the details of that in various ways, but that's the idea. You can change what happens at each of those frames until it blows up. So in this case, that doesn't look like it's indented correctly. What is up with that? Oh, no, it's just the way it was scrolling. Okay. All right. And then also, here's another thing that's just as important as initializing the clock worker. I want to say clock worker.add task. And then from the sprite component, I'm going to call move sprites. Okay. So the sprites are not going to move unless the clock worker has been started and we've told it to move the sprites. So those are two things that you have to do as part of initialization. Yes.
So is that kind of like appending a string to a string builder? It's kind of just adding it to the clock worker
So the question is that just like appending a string to a string builder? Is it just adding it to what the clock worker does? Yes, it is. It's just adding it to the list of things that the clock worker does. The clock worker takes a list of these tasks and it just run every tick of the clock. It just runs them all. Yes. Can I go over what again? Oh, tasks. So a task is just a thing that that the system will do every tick of the clock. And it can either have a finite number of times or an infinite number of times that it runs. Now, this move sprites thing is a task that's going to run an infinite number of times. But up here, I have a task for my plasma bolt. And what that's going to do is it's going to have a fixed number of steps. I think I picked 225. 225. And each step, it's going to draw the circle up for the plasma bolt a little bigger. And it's going to, toward the end, it's going to turn it yellow. So let me just show you again how that looks. So you see, it looks, it's red for a little bit, and then it turns sort of yellow and gets big. All right. So that's how you control that, is with that task. Okay. Any questions? All makes perfect sense. I'm sure it does. I'm sure you won't have to even go back and study this. It's just all in your brains now, right? Okay, so yes, you're probably going to have to go over this. You're probably going to have to look at this code in detail. You're probably going to have to maybe rewatch this lecture. I don't know. All right, so let's take a look at the Falcon class itself. Okay, this is also in Basic Flyer. So the Falcon extends sprite. All the actors on our little sprite component screen are going to extend sprite. Yes.
When you like type Falcon on the flyer, is that like calling this Falcon?
When I type Falcon.
When it says Falcon on the
yeah, so in the other code, when I referenced the Falcon, right, it's this class, right? So when I said new Falcon, this is where Java finds the code for Falcon. Yes. Okay, so in here I have a picture, which is my initial picture. I have some other constant I defined. I have a public, I have a name which matches the class name, and no return value, so that's a constructor. Okay, I have a constructor, it takes a scene, it's going to call super with SC. Remember, we talked about keyword super and keyword this in constructors. So the base class sprite takes a scene. Therefore, I have to call that super constructor first thing in this class to pass that on down to the sprite class. Okay, so that any sprite that you create has to take a scene as an argument and has to call super SC in order to compile and work. Okay, next I'm going to take a picture. I'm going to get the picture Falcon, right? That's my initial picture. I'm going to set the picture. Okay, so this tells the system how the sprite should look. I can do a dimension that's going to be, I'm going to ask the scene for a size, and it will give me the size of the scene. And then I can set an X component and a Y component for my sprite. I'm going to put it in the middle of the screen. Yes. Scenes are public. Well, yeah, I want to know what scene the sprite component is currently using, right? So the sprite, when the sprite component is initialized, it has a default scene. I use get scene to get that default scene. I can create a new scene and set it, but by default, it's going to have one. Okay. And then I'm going to set the velocity. I'm going to set X and Y. So this is just going to make it move in the X direction and not in the Y direction. So it's just going to go to the right. Make sense? Okay. I have process event, sprite collision event. So in this case, what's going to happen is the sprite collision event is going to detect when I hit a wall, right? So and when it hits the wall, it's going to have this sprite collision event is going to have X low, X high, Y low, and Y high. depending on which wall it hit. Okay, so if it hit the X wall, what I want to do is I want to set a new X coordinate. So if I hit the X low wall, that means I hit the low side of the X. Then I want to put it at the right-hand side of the screen. So what I'm going to do is I'm going to get the full size of the screen. I'm going to get the width of that, and then I'm going to subtract the width of the sprite itself. So I'm going to take the sprite and move it over to the other side of the screen. And if I hit the high end, then I'm just going to set the sprite position to 0 in the X coordinate. So if it hits the high end of the screen, it jumps back. And likewise with Y low, I'm going to go, if I hit to the top of the screen, I'm going to move it to the bottom. And if I hit the bottom of the screen, I'm going to move it to the top. So this kind of like makes it look like it's a spherical world. I go off any one side and I come on the other sides. And that's what this method does. So let's just look at that again. So my sprite's going to the right. It hits the right wall. It pops on the left wall. All right. If I turn and go down, it goes off the bottom wall, comes on the top wall. Any questions about that? All right, good. Okay, and that's all there is to the Falcon, right? That's all there is to the Falcon. Let's take a look at the plasma bolt. So in the plasma bolt is also a sprite, just like the Falcon is. It's a thing that moves around on the screen and interacts with stuff. I have a method on here called make ball. I think I replicate this method in other parts of the API, and I call it in various ways. It's just a convenient way to make an image that's just a circle of some color, right? So I have a color and a size, and what I do on basic frame, there is a create image method, right? Which will create an image for you to use. And then on the image method, there is a get graphics method. And the graphics object is the thing that allows you to draw. In this case, I'm going to set a color for my pen, and I'm going to call the fill oval method. You can look up the methods on graphics and see what all the things you can do with it. Okay, and then I say new picture, and I encapsulate that image, and that creates a picture object for use by the system, you know, as an icon for the sprite or anything else I want to do with it. Make sense? All right. Here's my constructor. All I do is call super SC and then set the picture to a ball. And then I have a process event method, which does nothing because there's nothing for it to hit because there's only the Millennium Falcon in the game. Yes, Drew. Yes, I'm going back to the make ball method. What's the issue? Yes. Picture is a class. It is a type. It is a class that I wrote. It's part of basic graphics. So if you're in IntelliJ, for example, you can click on that. You can hit Control B, and it will take you to the source code for that. So what I had to do, I had to call the constructor of picture with an image in order to get that return type. So I said new picture, and then I passed the image. The class is the return type. So the return type of make ball is picture, and so I have to return a picture from it. And so I have the last line is a constructor for picture, and picture can take a number of different things. It can take a string, in which case it will go and look for the file, or it can take an image object and it'll just use it. Yes. How did I add the pictures and sounds to the actual class? Well, in this one, I just construct the picture myself. Alternatively, I have an images directory, and I just put the image in there. If it's a PNG or a GIF or a JPEG or whatever, I just put it in there. And I have a sounds directory. And if I have a WAV file, I just put it in there, and then the system has access to it. So that's all there is to that. Drew, did you have another question? All right. Okay. So are we doing okay? Yeah, we're loving it. All right. All right, let's take a look. I've got some other examples here. Let's take a look at dog. Dog is also a very silly application. So well, so he isn't shot. It's just a question of how I I just did an imperfect job of getting a transparent image. Now you notice the scene did not change. The scene did not change when he hit the right wall, but it did when he hit the left wall, right? So that's one of the things that we're doing here is we're changing the scene. And here we go. And it changes again, changes back to the original one. Wow, isn't that special? Okay. He's teleporting. He's got holes in him. He is a zombie dog. All right. So let's go to the dog code. Come on. Basic. Where is it? Where did I put it? There it is. Walk the dog is the name of the package. And in that I have walk dog and I have dog. So let's go to walk dog first. All right. So walk dog. We have package name. We have imports. We have class dog extends sprite. We have public scene, scene 2. So what I'm keeping track of a second scene with this dog. I have the picture that I'm keeping track of the picture name. So I'm going to say inside my constructor for dog, I'm going to say super SC. I'm going to set the base picture equal to picture. And then I'm going to call set picture base pic to set the dog's picture. And then I'm going to create this constant del equal 0.1. I'm going to create a clock worker, add task. And what the clock worker is going to do is it's going to set the heading offset on the dog, which is going to be its angle. So you noticed as the dog was going across the screen, it was bobbing up and down. That's what this clock worker does. Yes. Name. Cooper. Yeah. What do you want to say? Yeah. Okay. How many? So Cooper wants to know how big is the screen that I've got here, and I think that by default I set it to something like 800 by 400. You can change that, right? There is. I will show you how to do that. There's a way to change the size of the default size of the image. I like the size that I have because if I'm running your game, it works on my computer. And that's important to me. But ideally, if you're trying to build a good app, you want it to work if somebody resizes it, right? And so often I have these kids who write these apps for this gigantic monitor that they have with 8K or whatever. And if you resize it, it turns to garbage. And I have to. It's hard to grade those. So anyway, I give you a nice default size for me, and you can change it. But if you want to make things easy for me, you won't. Okay, so what I'm doing in this thing is I'm saying. Yeah, I'm saying that if the count is equal to 100, I pick one heading. If it's 200, I pick the other heading. And whenever it gets to 200, I reset it to 0. So every time I call this add task, it does a plus plus. So it's just going to sort of only do something every 100 times. Ty. Yes. So the question is, if you were going to implement animations, would you do it through the clock worker? And yes, absolutely you would. So if you want to have, like my dog here has got very primitive animation that it does as it goes through its life, right? If you want to make something more sophisticated, something that changes every frame and rotates every 100, you know, it's got like a guy dancing or something, you can do that. Okay. And then I have the count that the dog is using to keep track of what its heading is here. I have a process event, and what I'm going to do is I'm going to detect whether I collide with the wall, and whenever I collide with the wall, I'm going to and my velocity is negative. I'm going to change the scene, and so what I'm going to do is I'm going to call this migrate method. And I'm going to give migrate method. I'm going to pass the scene I want to migrate to. And then I want to give it the X, Y, and velocity of my dog on the new scene. Okay. So I'm going to move that. And what it's going to do is it's going to return the old scene. And I'm going to put the old scene into scene 2. So the next time this method gets called, it'll switch it back. Right? Make sense? All right. And now I have my, what I do to reverse the direction, I just say, get the X velocity and set it to minus the X velocity. So that makes it switch. Scott. You can steal images. You can use AI to create images because we're not selling this. This is just a project you're turning in. Just make it look pretty for yourself. You don't, this is not, you know, this is not something that, this is not a commercial product, right? So just make it look pretty for yourself and don't worry is my feeling. Yes. Name again? Brad. Well, I'm using it, first time I called get velocity, I'm using it to decide whether to change the scene. The second time I'm using it because I want to reverse it from whatever it was. Now, I could have called it once and saved the value in a variable and just used the variable. That's another thing I could have done, but it's equivalent. Any other questions? All right. Sprite component. I create a sprite component. I get the scene. I create a second scene. So you can just call create scene to create a second scene. I set a painter for each of these scenes. Each painter uses a background painter, which uses just an image file. I construct my dog with a get scene. I put scene 2 as the scene 2 that I created. I set the velocity to -1, 0 as my initial velocity. I mean, you can just pick whatever you want for initial velocity and position. That's what I did. I set a dog heading, which was just math.py. So it's just going to go to the left. I create my basic frame. I create a layout with just one thing in it. I set that layout. I add the dog. That's dog. I put my sprite component there. Set preferred size, new dimension. Okay, so this is how you would change the size of the application, right? I am explicitly setting this application to 800 by 400. And the way you do that is you say sc.preferred size. That tells you that, well, that tells you the size of the sprite component, right? The size it prefers to be. I don't need to do that here. That's kind of old code. I call show because I always have to call show. I call add task move sprites because I always have to call add task move sprites. And I call initialize with 10 milliseconds because I always have to call initialize and I have to pick a number of milliseconds. And yes, you could pick 1 to get the highest possible frame rate, but that might not work out to give you the smoothest experience. It might even be too fast to play for whatever it is you're doing. So you have to play with those. That's a number that you have to sort of play with and decide what works best. The cool thing is, if your application is going really fast and you're having a hard time debugging it because you can't make your character jump high enough at the right time to get in the right spot, you can set that to a bigger value and it will just slow everything down. Okay. All right. I guess we'll call it here and we'll pick up this narrative again next class.